Hello again, AI Legends, and today welcome back to another first look video where we are exploring another agent framework. So today I'm going to be looking at the HuggingFace framework, which is called SmolAgents. And this is a really playful logo that they have. I like it, where there's that 007 theme going on about a license to call. So license to call APIs and tools. I really like it. Again, this is going to be quite a usual format that we're going. So initial feature set on the library or framework, followed by a quick demo, and then my final thoughts on the framework. And let's just get straight into it. So behind here, what we're looking at is a run through of how the agent works, at least in terms of how SmolAgents think of it. And we're going to run through the nice video that's going on at the background. But just to let you know, on outset, SmolAgents is really nice because it's already simplified lots of this thinking under the hood, and it's quite tight in its implementation, so it's pretty small library, not too bloated, and apparently they do it under 1,000 lines of code that already takes into account all this under the hood. So what actually is an agent and how are they formulating this? And this is what they're thinking of, where an agent is comprised of an internal LLM in orange, and it's given a series of prompts via chain prompting, role playing, and also advanced prompting techniques, especially the React framework, which is going to use quite a bit to guide its actions. So what's a React framework is basically the agent is going to have two components of its thoughts, where it's given a thought component or it thinks about its task, and then it takes an action. And the agent kind of cycles through this process eventually to get to a final output, and it retains memory in that process. So with each step, its thoughts get closer and closer to the final answer. Okay, so we can run through the video now and see. So right here at the top, we have a system prompt of a task, which is given to a LLM, which is in orange. And the LLM thinks, okay, maybe I should use a tool here. And it calls that tool. And that gets added back to the initial prompt. So with memory now, it has more information, which goes through the LLM again in the second pass and gives you the final answer. That's essentially what's happening under the hood, right? Okay, and a second component of SmolAgents, which I find quite interesting and quite unique compared to other frameworks out there, is that the code agents are the primary agents or first class agents in the framework. And this is a pretty interesting idea, where it comes from this archive article about that's called executable code actions elicit better LM agents. So essentially, they're saying that using code instead of the usual text prompting chat interface within the agents, that saves a lot more actions and a lot more tokens. So here, for example, on the left side, you see kind of back and forth between the agent and the output, the actions, where it's like, okay, I'm going to take this action and work through the steps to get the final result. So on the right in the green, what the SmolAgents team is doing is passing a prompt to the agent, and the agent's already given a Python environment where it can write and execute code in there. And in one block, basically, it's gonna find the final output that's required for the answer. So I think this is nice because you get less calls, less API calls to a provider. So we're gonna see how this pans out in the demo. Yeah. Okay, here we are. So here I have a quick demo that I've built up. And in this example, it's a automated task where I want the agent to rank a series of article that's given to. So here I'm going to give it a task, say, this is a whole bunch of articles. Can you rank in priority which one I should read? And that task will get passed into SmolAgents. And here I've given it tools. So the tools that it's going to use would be first a tool that can read the files, and then a Python tool that will strip the text, so get it nice and clean, and then summarize it. So and then so agent will work in steps and iteratively to get to its final output and rank the articles from 1, 2, 3, and so on. Okay. So again, a very broad and high level task. Like, hey, this is a, a bunch of tasks, bunch of articles that I want you to look at, and I'm not actually specifying the exact ranking or how you're supposed to do it, but rather giving tools where you can kind of figure out what to do in between. And additionally, today I'm going to also add on a telemetry bit to it, so we can look at the tracing and what the agents are doing under the hood. All right, so I'm going to jump to the demo now. And here's my cursor environment. So I have the sources and the files on the side here. I'm going to execute the agents. Fingers crossed. All right, here we are. So this is the prompt that's given to the agent. Say you have a bunch of articles and these are the tools that you're given. So you got to be quite specific in telling the agents what you want to do. These are the tools that you're given, what are the tools used for, and be quite granular in that. If not specific enough, unfortunately, the LLM is going to miss that out. And here I want its final output to include a article, score, and some reasoning. Okay, so it's going to go through a few steps here, and I quite like already that the HuggingFace theme has put in some effort to make a nice colored terminal output. I'm going to be using the new Gemini 2.0 flashlight here, so a super new model that's made by Google, probably a competitor to O3 Mini. Really nice, really fast. I really like it, and it's also multimodal, so really awesome. So here, I'm just gonna give it a couple seconds to run, and we'll come back to it. Okay, it's been about just 30 seconds, and it's done the job of categorizing 10 different articles already. So here in the first step, it's already gonna use the first tool to read the files in a folder. So this is basically a Python function that I've given it, read MD files. Okay, so it's that I've got 10 articles to read now, and it's gonna clean these articles iteratively. So it's interesting here in this section. I didn't write this code here, but it's already using Python and making a list, an empty list, which gonna store the clean articles as an output. So it's gonna use this tool here, summarize articles, which is a quick strip tool that I made in Python, where it's just stripping empty spaces. Not really bothered to show code here. It's really, really simple, just a couple of lines of code. But again, the agents are smart enough to pick it out and use it, and write additional code on top of that to work with the tool. Okay, I'm gonna skip past these outputs here. And here in step 3, the agent is coming back with the summarized articles, and it's making a kind of ranking algorithm, a very basic one, but I would say pretty nifty, given that I didn't actually specify exactly what kind of score to use, how do you score this, what sort of relevance. So it's using a keyword search and keyword identifying kind of strategy here, where it's looking for specific things like AI agents or Gen AI, and it's going to say, hey, that's really important for this business. Yeah, I mean, pretty decent. It's got a functioning Python code already that's going to parse through the articles here. And at article 1, it's ranked the highest, and article 6 is ranked the highest, where it's going to focus on AI agents, great for AI startups. There's some mention about Gen AI and the customer segments here. So some reasoning given, which is pretty alright. And I've also given it a crappy articles, messy articles, and there's another article about cats here, which it's rightly picked up at number 10. So it's didn't even bother ranking it and said, oh, this is gonna score 0. So a pretty alright sifting tool at the outset. And yeah, we're gonna jump over to the telemetry to see what's happening as well. So here we have Phoenix Arise, and this is the telemetry or tracing tool that I've been playing around a lot with this same project. It's an open source project as well, so really cool. So here we can open it up. And this is the latest run that I've done. So I've done it in about 30 seconds. And we can open up the run to see what's happening under the hood. So it's going to tell you the outset is run for about 20 over seconds. And the first step is going to use that tool, how long it's going to take, and what happens under the hood, how the agents are thinking as well. So I really like it here. So you can see under the React prompting that the SmolAgents is using, it's all over here in the system prompts, and you can see what agent is doing with it, what tools it's gonna think to use, and so on. All right. So overall, I quite like this. I think maybe I like this a bit more than Kura even. And I'm gonna jump to my thoughts on the framework. Okay, so here we are. My final thoughts on the framework, again, summarized in very quick terms. First off, I really like how it's a light framework and it's very simple. So I think there's beauty in the simplicity of things. And again, here the team has done well by writing the whole logic in about 1,000 lines of code. So really sweet. There is first class support for tools on the HuggingFace hub, like Grotto Spaces. You can immediately plug this into SmolAgents already, and even had some fun with some models like Quencoder. So it's really accessible via the hub already. Okay, but again, you're not really limited to use just HuggingFace hub. You can use any provider like LLM, which I use to connect to Gemini. You can use the open AI API outright or even local models. Yeah, so again, very intriguing bits about this framework is that the code agents are the primary agents in use here. So I think it's nice. It's kind of cut down the token use and the latency bit of things. So I like it. I did test out a more complex multi-agent system where you have a manager system like a hierarchical model, and there'll be different sub-agents doing smaller things. But for this task, unfortunately, it didn't really work out for me, and maybe because of the task complexity. So what ended up is each run is going to use about 1 million tokens for me, which is insane. And the output actually fails because the agents are getting lost in its communication between the manager agent and the sub agents. So I think a bit more testing for me to do there, and maybe finding a more difficult task perhaps. Not sure, but do let me know. Or maybe again it's skill issue. I don't know. But do let me know your thoughts in the comments. All right. And my last final thought on SmolAgents is that it's got a huge advantage in where you can write really Pythonic tight tools for the agents to use. So it's really handy to get targeted outputs in exact formats that you want to do specific calculations under the hood. I really like it. I think that's kind of Achilles heel of LLMs in any way, counting stuff, doing tight numerical sort of work. That's really reserved and really suited for Python itself anyway. So yeah, that is my thoughts on SmolAgents. Let me know if that's something that you are building as well, or what else that you want me to cover. Do let me know. But otherwise, we'll see you in the next one, AI agents. All right, take care and bye bye.